Picture a laboratory in 1945. The equipment around you was built for radar, not dinner. According to the famous story popularized years later, a snack in an engineer's pocket began to heat up. That engineer was Percy Spencer of Raytheon, and this moment became the famous origin story of the microwave oven. You may have heard that a chocolate bar melted in his pocket and the microwave was born on the spot. The best evidence gives us a more interesting version. The pocket snack belongs in the story, but it wasn't a finished appliance, and even the snack's identity has changed in the retelling. A profile published in 1958 called it a peanut bar. Later versions often turned it into a chocolate candy bar. Either way, the useful question isn't whether lunch had a bad day. It's why Spencer understood that the accident was worth investigating. Spencer already knew the machine beside him extremely well. It used a magnetron, a vacuum tube device that generates powerful microwaves. During the Second World War, magnetrons were central to radar systems. Spencer didn't invent the magnetron. His documented contribution was finding ways to manufacture magnetrons far more efficiently at Raytheon. The National Inventors Hall of Fame says production rose from 17 units a day to 2,600. That background matters. Plenty of people can notice something warm. Spencer had the practical knowledge to connect unexpected heat with microwave energy and the authority to push for experiments. That reported accident met an engineer who knew what question to ask next. According to the 1958 account, Spencer followed the warming peanut bar with two memorable tests. He brought popcorn near a magnetron and watched it burst around the lab. Then came an egg inside a kettle with a hole cut into its side. The egg heated unevenly and burst near a skeptical engineer. It's a wonderful sequence: snack, popcorn, exploding egg, invention. It's also a story published more than a decade after the events. A later engineering history drew on recollections from people who worked at Raytheon. They remembered microwave cooking developing gradually through several observations, including warmth near radiating tubes and experiments with food. Spencer was still pivotal. He helped turn scattered observations into a company project, but the evidence doesn't support treating one pocket snack as the entire invention. This is how neat invention stories are often made. A vivid moment becomes the symbol for a longer process because it fits in one sentence. The laboratory work usually doesn't. The firmest date arrives in the patent record. On October 8, 1945, Percy Spencer filed a patent assigned to Raytheon for a method of treating food with microwave energy. The drawing doesn't show a familiar kitchen box. It shows magnetrons feeding energy through waveguides, metal passages that direct microwaves, toward food traveling on a conveyor. The speed of the conveyor would control how long the food stayed in the field. The patent describes experiments with an egg and a potato. More importantly, it explains what Spencer believed was new. Electromagnetic energy had already been used to heat food at lower frequencies. His claim was that microwave wavelengths could make the process efficient and commercially practical. So the breakthrough wasn't simply discovering that invisible energy could produce heat. It was developing a workable method for concentrating microwave energy on food. The candy story gets you into the laboratory. The patent shows the engineering that came after it. Even that first patent wasn't yet the appliance on your counter. Food moved past an exposed outlet from a waveguide. A controlled metal enclosure was another step. In February 1947, Spencer filed a patent describing high-frequency heating inside a metallic cavity powered by magnetron oscillators. The metal enclosure kept the microwave energy in a defined space where it could heat an object placed inside. Now the basic architecture looks familiar. A magnetron generates microwaves, a metal cavity contains and reflects them, and food sits inside that cavity. Turning a reported heating effect into a usable machine required control, shielding, power supplies, cooling, and a door that could be operated safely. There was rather more involved than removing the wrapper from a peanut bar. The early commercial machines didn't look convenient. Smithsonian and engineering histories describe the first radar range ovens as roughly 6 feet tall and about 750 pounds. They were water-cooled and intended for places such as commercial kitchens, not a narrow shelf above the cooker. Imagine buying a quick way to heat lunch and discovering that lunch now requires industrial equipment and plumbing. The machine then spent years shrinking. Tappan offered an expensive home model in 1955, but it remained far beyond an ordinary kitchen purchase. Raytheon acquired Amana in the 1960s, and an Amana countertop radar range arrived in 1967. It was still costly, but it finally resembled the domestic appliance that followed. The journey from radar laboratory to countertop took more than a lucky observation. It needed smaller components, better cooling, safer enclosures, and a market willing to learn a different way of cooking. A modern microwave still carries the same central idea. The magnetron produces microwaves, which are a form of non-ionizing electromagnetic radiation. The metal interior reflects those waves, and food absorbs their energy as heat. That doesn't mean thick food cooks magically from the inside out. The United States Food and Drug Administration explains that the outer portions are heated mainly by microwave energy, while heat still travels farther inward by ordinary conduction. It also says the absorbed microwave energy becomes heat and doesn't make the food radioactive. The famous pocket snack is therefore worth keeping, as long as we don't ask it to carry the whole history. It captures the moment when an unexpected effect demanded an explanation. The microwave oven itself came from what followed: wartime radar expertise, repeated experiments, patentable methods, an enclosed cavity, and 2 decades of refinement before the machine became at home in a kitchen. A peanut bar may have helped focus Spencer's attention. Engineering turned that warm pocket into an appliance. If you enjoy strange histories hiding inside ordinary objects, subscribe and watch another video on the end card.